Freshies! Welcome back to another episode of Learning Mathematics here at DepEd TV. I am Teacher Belle, ang iyong kaduo sa Math 7. This is a new day for fun and exciting learning in mathematics. Together, let's be Math Tibay, Math Talino, and Math Galing!
Exciting, discover new topics that are amazing. You can surely enjoy this thing. Be math galing, be math galing. You can surely enjoy this thing.
As we are starting with today's task, I want you to bring out your pen and your self-learning module. Ready? Lo and behold, it's time for us to explore the subset of real numbers. Mathematical knowledge should consist of a deep understanding of the number system, the system of real numbers. We will study how each subset in the mathematical system is dealt with. Let us take a look at the basic subsets as they successively develop into the bigger set, which is the set of real numbers. Let's take a look at this picture. The figure shows the relationship of various kinds of numbers in the real number system. And these are the subsets of real numbers. It is said that a family that connects to one another lasts forever. This is just like the subsets of real numbers. Let us read and study the acrostic to better understand the subsets of real numbers. The real numbers family. Letter F. Form a strong bond with all your rational and irrational members. Letter A. Always remember integers and fractions may be in different places. Letter M. Make cool, fun, and memorable moments. Letter I. Ignore the negative differences. Letter L. Love and count them while you can. Life can be short. Letter Y. You can't be the zero. Keep them together for a happy ending. From the acrostic above, the underlined words such as rational, irrational, integers, fractions, whole, count, and zero are the subsets of real numbers. Let us discuss it one by one. One of the subsets of real numbers is the set of counting or natural numbers. This subset consists of all positive integers that we use to count, starting with 1. The subset would look like this: 1, 2, 3, 4, 5, and so on. Another subset is the whole numbers. This subset contains the counting numbers and 0. The subset would look like this: 0, 1, 2, 3, 4, and so on. The third subset is the integers. This subset includes whole number, not a fractional number, that can be positive, negative, or 0. The subset would look like this. The next subset is the rational numbers. This subset includes all numbers that can be expressed as a fraction or numbers with non-terminating and repeating decimals. Examples of rational numbers are 5 and 34 hundredths, 6/7, and 0.13 with a bar. Lastly, we have the set of irrational numbers. This subset includes numbers that cannot be expressed as a ratio of two integers. It has decimal that goes on forever without any repeating pattern. Examples of irrational numbers are square root of 2, 4.6265, and so on, Euler's number, and pi. To summarize, let's take a look at this family tree of real numbers. The set of real numbers is divided into two: rational and irrational numbers. Under rational numbers, it can be an integer or fraction whose denominator is not equal to 1. An integer is consisting of negative numbers and whole numbers which are positive, and whole numbers are made up of 0 and counting or natural numbers.
Let us see if you have familiarized yourself with the subsets of real numbers.
Classify the real numbers to which subset of real numbers they belong. Use a tick mark to answer. You have 30 seconds to finish the activity. Timer! Time's up! Now, let us answer your activity. We have -3. It is an integer and a rational number, since it can be expressed as -3 over 1. 0. It is a whole number, an integer, and a rational number. 4 over 7 is a rational number. How about square root of 2? It is an irrational number, since this number cannot be written as a ratio between two integers. And last but not the least, 5/10. It is a rational number since it can be written as 1/2.
Good job for accomplishing your task! We will now have some tidbits or nice facts related to our topic on the subset of real numbers that will once more evoke the beauty of mathematics. I hope it shall allow to flourish in you freshies the intrinsic love for existing mathematical structures, which, for all I know, several of you weren't aware such structures actually exist.
Decimal fractions. The term decimal fractions first appeared in the year 1585 in a pamphlet entitled De Tiende that was written by the Flemish mathematician Simon Stevin. Some examples of these are 53 over 100, 2 over 10, 386 over 100, and many more. Irrational and rational numbers. Towards the end of Pythagoras' life, Pythagoras founded the Pythagorean community. He married one of his most successful students, Theano. She is an accomplished cosmologist and healer, and later, Theano headed the Pythagoreans after the death of Pythagoras. All throughout his scholastic years, Pythagoras also stressed the importance of whole numbers in the study of nature. Thus, the motto, all is number. After his death, his followers were able to establish that square root of 2 cannot be written as the ratio of two whole numbers. since many of their founders' widely accepted conclusions in those times were based on this flawed assumption that all numbers could be written as the ratio of two whole numbers, his followers tried to keep the discovery secret. Legends say that one of his followers, Hippasus, revealed the secret and as a result was thrown overboard by his fellow Pythagoreans while they were at the sea. 0. God made everything out of nothing, but the nothingness shows through. Paul Valéry. The most universal word for this today is zero. Like nil, it originated in Italy, thanks to the legendary mathematician Leonardo Fibonacci. Leonardo took the Arabic word "sifr", meaning empty, and gave it an Italian flourish. So he called it zefiro, which was later abbreviated to zero. This also gave us another word, zephyr, which is used to refer for a faint, almost non-existent wind. Can you think of other words that sounds like zephyr, which may be linked to the idea of nothing or empty? Comment it on our Facebook page, Math Galing, Grade 7 Mathematics. Great thoughts about our trivia! You are indeed Math Galing! It's good to know that you can now classify the real numbers to which subset it belongs. This time, let us arrange real numbers in increasing and decreasing order on a number line. Consider this problem. Ben traveled 4 kilometers from their school to the left, 0 being the place of origin. And Chad did the same, but traveled 2 kilometers longer than Ben. On the other hand, Kent traveled to the right, starting from the same origin with a distance of 3 kilometers. Place those people on the number line to find their position from the place of origin. That shows an order. Starting from left to right, we can arrange them in order as Chad, Ben, the school, and Kent, or using numbers on a number line as -6, -4, 0, and 3. If we want to order real numbers, these steps will be helpful in doing so. First, change each number to decimal. Second, write the decimals in order from least to greatest or greatest to least. Lastly, write the numbers in the new order. For example, arrange 2.55 with a bar, square root of 9, 15/4, -11/5 in ascending order and plot the numbers on a number line. Step 1. Change each number to decimal. 2.55 with a bar is equal to 2.56 rounded off to the nearest hundredths. The square root of 9 is equal to 3. 15/4 is equal to 3 and 75 hundredths, or 15 divided by 4 is equal to 3 and 75 hundredths. -11/5 is equal to -2 and 2/10. Changing fraction to decimal, -11 divided by 5 is equal to -2 and 2/10. Second, since it should be arranged in ascending order, we need to start from the smallest number. If we have 2 and 56 hundredths, 3, 3 and 75 hundredths, and -2 and 2/10, we will be starting with -2 and 2/10, followed by 2 and 56 hundredths, then 3 and 3 and 75 hundredths. Lastly, write the given numbers with their new order. Negative 11 over 5, 2.55 with a bar, square root of 9, and 15 over 4. We are now ready to plot the points on the number line. In here, we can estimate the location of each point on the number line based on the given values. Let us plot each number on a number line. Negative 11 over 5 is equal to negative 2 and 2/10. 2.55 with a bar is equal to 2 and 56 hundredths. The square root of 9 is equal to 3, and 15 over 4 is equal to 3 and 75 hundredths. It's your turn to try this example. Arrange the following from greatest to least. Square root of 4, negative 5 halves, 3/4, and negative 30 hundredths. Plot the numbers on a number line. Timer! Let's see if you got it correctly. Step 1. Change each number to decimal. Square root of 4 is equal to 2. Negative 5 halves is equal to negative 2 and 5/10. Changing fraction to decimal, negative 5 divided by 2 is equal to negative 2 and 5/10. 3/4 is equal to 75 hundredths. Changing fraction to decimal, 3 divided by 4 is equal to 75 hundredths. Negative 30 hundredths is already expressed in decimal form. Second, if we have 2, negative 2 and 5/10, 75 hundredths, and negative 30 hundredths, and needs to arrange from greatest to least, then it should be 2, 75 hundredths, negative 30 hundredths, negative 2, and 5/10. Lastly, write the given numbers with their new order. Square root of 4, 3/4, negative 30 hundredths, and negative 5 halves. Your number line should look like this. By plotting each number, we can see which is the greatest and which is the least number among the given set of numbers. For your last task today, let's apply what you have learned about arranging real numbers in increasing or decreasing order by solving the following problems. 5 students, Alan, Ben, Carlo, Daisy, and Eman of grade 7 ran the following distances in kilometers respectively in 2 hours. 5 halves, 3, 11/5, 2 and 8/10, and 13/4. Letter A. Which student ran the farthest distance? Letter B. Arrange the distance covered by 5 students from least to greatest. From least to greatest, the distances are... Timer! 5 students, Eman ran the farthest distance. Let us arrange the 5 students based on the distance each one covered from least to greatest. Carlo, Alan, Daisy, Ben, and Eman. You did a good job in applying what you have learned. For your assignment, read and answer the additional activities found on your self-learning module, number 10. That's it for today, but learning does not end here. In our next episode, we are going to learn about scientific notations. Again, this is Teacher Belle, ang iyong kaduo sa Math 7. I hope we help you become math tibay, math talino, and math galing!